Hello everyone, welcome to this video on the AERO2356 Wind Tunnel Lab. Here I'll be taking you through the wind tunnel itself, the aircraft model setup, and a test example where we'll be setting the angle of attack, airspeed, and acquiring our data. So this is the tunnel we'll be using. It is called the Blue Wind Tunnel at RMIT. It's quite large and extends the width of the building. You can access it by climbing these stairs in building 252. Over here you can see the entrance hatch where you access your experiment. So you just close these doors when you begin your experiment. Over here we have our power supply to the wind tunnel. And finally our airspeed controller here. And in addition to that, a dynamic pressure indicator, which is measured via a pitot-static tube in the tunnel. So, before operating, we need to ensure that the hatch is securely shut. Next, ensure the key is engaged and the wind tunnel has power. Next, on our right, we need to ensure that the pressure indicator is correct. It should read about 0 kilopascals, and so we should keep an eye on this through the test. So, to begin increasing the airspeed in the tunnel, we'll turn this dial right, and you'll see that the pressure indicator will begin to increase. As this is increasing, the tunnel can get quite loud. After a test, ensure the dial is turned all the way left and the pressure indicator reads 0 kilopascals. In this experiment, we will be analysing the relation between change in angle of attack and the resulting pitching moment. The only control surface we have is the elevator at the back, which is constrained to the neutral position. As you can see, the fuselage and tail of this model is a flat plate. This was designed specifically for this analysis as we want to exclude the effects from these in the longitudinal and lateral directions. As mentioned before, there is only one actuator here, the elevator, and it is fixed in the neutral position with tape. You can also make note of the pushing rod here. To reiterate, the elevator is not deflecting in this experiment. There is an additional weight at the nose as we want the center of gravity to be ahead of the support. This support is attached to a force balance at the base of the wind tunnel. Firstly, to change the angle of attack, we'll be focusing on the pivot point around the support over here. You will need a 3mm Allen key to undo the bolt holding the model level. So once you've undone this a bit, you'll see that the aircraft will begin to loosen and you can freely move it around and change the angle of attack. So for this example, we're going to set the angle at about 4 degrees. And then finally, you want to tighten the bolt to ensure the plane doesn't move when the wind tunnel is on. Once you have selected an angle and the bolt is fastened, you need to take this angle meter and place it somewhere flat, such as the top of the fuselage. Your lab partner should be outside, looking in through the window to assist you in reading the angle. Further adjustments may need to be made. Once you have set your angle of attack, we need to set the wind tunnel up for operation. Begin with closing the doors. Next, we'll power up the wind tunnel, turn the key right, and press the green button. Moving back to the desk, we can see the sensor outputs from the force balance. So below, we can see the forces in X, Y, Z, and the moments, and then where this is connected to a HBM data acquisition system. On the screen here is the software to visualize and acquire the forces and moments. As we can see here, we have voltage signals, and these are converted to the correct outputs for force and moments. Before we increase the airspeed, we need to calibrate the force balance, so ensure all these sensors are highlighted here, and then click execute at the top. So once the force balance has been calibrated and you're ready to begin, we need to find what dynamic pressure we'll be operating at. So the way we find this is what airspeed you've chosen to operate at. So for example here, we're going to take 10 meters per second. Using the dynamic pressure formula and taking 10 meters per second, we find that the dynamic pressure is 0.061 kilopascals. So we need to ensure that we reach this target on the pressure indicator. So slowly increase the dial until we reach that pressure. This can be a bit tricky as the dial tends to overshoot, so be sure to turn this slowly and keep an eye on the pressure indicator. As you see here, we have overshot a bit, so I'll reduce the dial back down. Once this is set and you're at steady state, come back to the computer and ensure you're on the DAC Channels tab. As you can see, we're still seeing zeros here, so what you want to do is click Live Update and you'll see that all the forces and moments are updated. So next, click on the Visualization tab and we'll begin to start recording the data. So hit Start. This window may appear, so just click Ignore at the bottom and you're good to go. Once enough time has passed, say 10 to 20 seconds, you'll want to click Stop and begin to save your data. So you'll be presented with this screen. What you want to do is select this icon and save your data somewhere. So usually for these labs, there'll be some folders set up and you can locate your team folder. So when saving each file, you want to give it some sort of meaningful name. So in this case, our airspeed was 10 meters per second. So let's call it velocity is 10 meters per second. And then we know our angle attack was about 4 degrees. So we'll put alpha and then 4. So once that's done, what you want to do is click Save. And then back at the previous screen, click on Save Data Now. Once you've saved your data, we want to make the system safe. So return to the dial and turn it all the way left until you physically can't move it anymore. This will reduce the airspeed to 0. Next, head over to the power unit and press the red button. Then turn the key to the neutral position. Finally, head over to the hatch. So we'll open the first door, move the latch, push it up. Then the second door is released via this lever here. Once the pin is in the base, it's safe to enter the wind tunnel. So we want to repeat what we did earlier. Take 3mm Allen key and undo the bolt at the top of the pivot to change the angle of attack. Once that's secure, get your partner to stand there and look through the window, where we will take the angle meter, sit it on a flat surface and ensure we have the right angle. Just a note on the angle meter, it is quite sensitive as you can see. So when using it, ensure it is a flat surface and take measurements as accurately as possible. Hopefully this was helpful, and please be careful when conducting experiments in the wind tunnel.